Hello, this is Liz Stockwell, and this is my Geog 883 final presentation, talking about the efforts to green urban greenery in Singapore and surrounding cities and how well it is mitigating heat island effect and other climate change factors. In order to run this comparison, I decided to we'll also look at two neighboring cities. To the north is Kuala Lumpur in Malaysia, and to the south is Jakarta in Indonesia. Um, I chose these because, again, they're nearby, so they're in a similar climate. So, starting with Jakarta, I did using Landsat 9. I created an NDVI map and a temperature map. And one thing you're going to notice is 174 degrees. What's going on there? Now, according to this, temperature in Jakarta on May 6th, which is when this image was taken, reached a high of 95 degrees, which is still pretty hot, but that's not 174 degrees. So what is going on? Well, this isn't the ambient temperature. This is the temperature that is being reflected off the surface. Now, if you're in a city in summertime and you touch the asphalt, it's going to be hot. And a quick Google search revealed that these kind of temperatures are not really unheard of for asphalt temperatures during extremely hot weather. And if you figure we're in the tropics near the equator, it's probably going to be even more so because the sun is shining directly on to this pavement. I also like to take this time out to tell you if you're going to walk your dog in the summer, cover their paws because that can burn. As you can see from the NDVI map, you have like little patches of green, probably parks and stuff. And these purple blobs are cloud cover, which I'm going to get to in a minute. So Kuala Lumpur on May 17th, this was Landsat 8. Let me try to get rid of that. Landsat 8. And you see a lot more greenery. There's probably larger parks. And yes, there are holes in the data. I tried to find another data set, but none of them really worked as well. And again, you have some clouds. High temperature on May 17th reached 93 degrees. So then we get to Singapore, which was the center of this. This was data taken on May 27th, 2022 by Landsat 9. Did the NDVI, came out good, but then I looked at the temperature map and I said, wait a second, that looks kind of weird. And if you look at the values, there's a wide range. Going back to Kuala Lumpur, you have like 55 degrees to 153 degrees. Jakarta is like 115 degrees, which yikes, to 174 degrees. And I realized negative 169 to 175 degrees, that is going to skew the scaling and the stretch. And I tried a few other stretches and I realized this is the problem here. So what is this? So these are the true color pictures of Singapore and Jakarta. And you see that you have, in Jakarta, you have these nice puffy cumulus clouds, while in Singapore, you can barely see them, but you can kind of see them. These are more cirrus clouds. And I'm not an expert in meteorology, but I'm guessing that this different kind of cloud cover is what is causing the temperature variance. Cumulus clouds have a high albedo. I mean, they're white. The light just kind of reflects right back off them. But I'm getting the feeling that these cirrus clouds are mostly water vapor, so they are causing a lower temperature reading, and that's skewing the results. So what am I to do? Well, get another data set. Unfortunately, the clearest data set I could get was February 20th, 2022. Again, this is Landsat 9. I wanted to try to keep it in May to try to keep these as close together as possible, but it turns out that in the tropics, cloud cover is a thing. So this is what we have. So I did another NDVI for this, and the temperature map, and you can see there are some cloud covers, but they are again cumulus clouds, so it's at least similar to the other two. Temperature reached a high of 93 degrees on February 20th, and you can see the temperature readings. So this is getting up to 187 degrees, which yikes. Um, and I want you to note this section here, which does seem to be a high center of heat and not much vegetation. I'm going to get to that in a few minutes. So what does this actually mean? Like, how do we compare these then? Well, with charts, and I apologize that these look very, very squished. So I took histograms of all three maps to get a distribution. And as you can see, Jakarta and Kuala Lumpur are very lopsided. They seem to have a lot of spaces with these like low temperatures, but not wide spaces, if that makes sense. And then you get to the higher temperatures above the mean, and suddenly you're getting a lot more area covered by these higher temperatures. Singapore, however, does seem to be more of a balanced chart, of a balanced distribution. The mean actually looks like it is in the center of these population numbers. So again, I did the same thing with the NDVI. I did a quick check, like what do these NDVI actually mean? Apparently 0.1 or lower is kind of barren. 0.2 is when you get into shrubbery. And then like 0.6 is when you're getting to like tropical jungle. So Jakarta has a low NDVI, and this actually makes sense. I'm going to go way back up here. It was very purple on the scale, which means it's a lot of negative spaces. But Kuala Lumpur is definitely more balanced. It has a higher average of 1.96. I'm sorry, 0.196, which again does seem to be more like a shrubbery cover, but it does kind of get up to the higher numbers. And Singapore has a higher mean, 0.2, just above where Kuala Lumpur is. Does I have this like sloped distribution, so it seems to have a lot of like smaller shrubs. It's kind of the bulk of it, and then as you know, there's like more and more, but there does seem to be more heavier vegetation in Singapore than in Kuala Lumpur, and definitely in Jakarta. I mean, Jakarta just goes to flatline. So this is a comparison of three cities. So it does seem like Kuala Lumpur manages to have the lowest mean temperature, but that mean is also on one side of a major lopside, whereas Singapore, it seems more balanced. And this is going to come up again. And also that Singapore seems to have more large vegetation, or more dense vegetation, I guess, is what this is saying. It seems to have more heavily like shrubs, which you expect in a city. So took a scatter plot between to see the relationship between the NDVI and temperature for Singapore, and the expectation is that this should be a downward sloping line. It's not. It has a slope of 4.2. Well, what's up with that? Well, and I kind of like I had to ponder this for a while. If you look at this, the higher temperatures are in the lower ends of the NDVI, and it doesn't so much decline as it kind of narrows. This cloud is narrowing. I mean, you have these outliers, but it does seem to be narrowing in a downwards trend. So, well, what does this mean? Well, we think of vegetation as having a cooling effect, and it does. However, in colder climates, vegetation has kind of the opposite effect. Thinking of the taiga, which is the northern forests covering California, Canada, and Russia, during the winter, caribou will stay in the trees where it's slightly warmer, and then in the spring and summer head out into the tundra. So vegetation has more of a mitigating effect on climate. So it's kind of balancing the two extremes between hot and cold. So this does seem to make sense. So, on to the other issue that people seem to be interested in, and it has to do with socioeconomics. Now, I could not find a good map displaying like socioeconomic status in Singapore. Some of the links I looked at suggest that Singapore tries to distribute its population to avoid having poor neighborhoods and rich neighborhoods. Um, but that's what the government website says. Well, what's actually the reality? Well, I was able to get a population density. This was from 2018. Could I have gotten anything more recent? Yes, but there were so many problems involved with all of those files, which I don't have time to get into. So here's a population density map, and yellow is the high end, next to the temperature map. I tried to put these on top of each other, and it looked terrible. I could not find a good color combo. Um, and again, I want you to notice this section here. It does seem to have, if it's like on this, it's kind of like a lower population boom, but then like this part seems to be more densely populated. And this is per 30 square meters. So I did another scatter plot, and I got this, which I found was very interesting. It seems like that it's not just talk. So the population density seems to be spread out pretty evenly among temperature variants. That you have these dense populations are in like the cooler sections of the city, and then you have like low population densities, which is in the warmer part of the city. And to get back, why did I go with population density? Well, because population density usually is a sign of socioeconomic status. Let's face it, most of us would rather live away from people. At least that's my dream. And I'm sure sociologists among you are cringing hard at this logical leap, but yeah. So what about versus NDVI? Where's the green vegetation? Do these densely populated neighborhoods have enough vegetation to surround them, which you would like to see, not just for its cooling effect, but for its psychological effects. And again, we have a very interesting looking scatter plot here that, again, these densely populated areas seem to occupy a pretty wide range. It does seem like the densely populated areas do have generally less vegetation, which you would expect. There's less place to put it. But you also have these not densely populated at all that are on all the way up to 0.45, which seems to be a very green area. So again, it seems like Singapore isn't just talking. It is actually trying to distribute the benefits of greenery across its city. So the last point, I had pointed out this section here. What is going on here? Well, it turns out, and I went to the hood map because this cracks me up. I also prefer this kind of map because this is user-based, which means that it is people who actually live there are giving the information. So it tends to be more honest than government websites, if you don't trust the government. And I want to point out that the rich sections, there seems to be spread out all over the city, or even in this section here, including a university. So if you look at, you can kind of barely see it. It says the Geog Industrial Estate is this area here. And it is a search for it, and it turns out this is the industrial center of Singapore. So it does make sense that this area is hot, doesn't have a lot of vegetation, and has a reasonably dense population, is the industrial center. And here's a picture of it. So, and even then, it's looking pretty green, but you can only put so many trees among chemical factories. So, that is my presentation. I'm going to talk to you about the data I used, different websites I used. The high resolution population density maps are from Facebook, which, wow. But they were using census data. And also a couple of websites about Geelong and Singapore. The Landsat I got from the collection 2, level 2. I had one from Landsat 8 and three from Landsat 9, one of which, the 527 one, obviously I ended up not using, but it's still in here, so it still gets a mention. And for tools, I used ArcPro and Google Earth. So thank you, and good luck on your assignment.